Hey everybody, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 8, looking at lessons 14 and 15, graphs of systems of inequalities. So to this point, when we've been talking about systems, we have been looking at equations. So equations have an equal sign. Inequalities, we're going to have an inequality symbol. And we looked in past unit at how we graph these inequalities. Remember, and you can see in that graph below there, we have a shaded area when we do an inequality. So here, when we have a system of inequalities, we are looking for basically a set of solutions that would make both inequalities true. It has to be, both of these have to be true in order to be a solution to a system of inequalities. And so with this first one, they want to know if these two solution points, if they would be solutions to these inequalities. And there's a couple of ways we could do this. We could graph our inequalities and see if those points are in our shaded area. We could also plug in, remember this is just an x value and a y value, so we could plug those into those inequalities and see if they make them true. I'm going to start with that method here. So in that first one, plug in 2 for x, and we're plugging in 1 for y. We want to know if this is true now. So 3 times 2 is 6. 6 minus 1 would be 5. And that's saying that 5 is less than 4. Well, right away, that doesn't work with that first inequality. So even if it works with the second one, in order to be a solution, it has to make both of them true. So it looks like 2, 1 is not a solution here. Let's try negative 6, 3. So I'm going to plug in negative 6 for x. I'm going to plug in 3 for y. And we'll see if it makes this first one true. 3 times negative 6 is negative 18. Negative 18 minus 3 is going to be negative 21. And negative 21 is less than 4. So it does make the first one true. Let's see if it makes the second one true. Plug in negative 6 for x. We're plugging in 3 for y. So we have 4 times negative 6 is negative 24. We have negative 7 times 3 is negative 21. Negative 24 minus 21 is negative 45. And negative 45 is not greater than 8. And so since neither one satisfies both inequalities, we would say that neither one is a solution. Let's look at what this looks like on the graph. So I've used Desmos to graph these. Let me minimize here. And so you can see here is one of them, has this red shaded area. Here's the other one, has the blue shaded area. The part where both shadings come together, it kind of creates this purplish area. This is going to be the area that has the solutions to our system. And so I've plotted those 2 points here. Here's negative 6, 3. It satisfied this inequality, but it didn't satisfy the one in blue. And then the other point, you could see it's outside of all of the shaded areas, so it didn't work with either of those inequalities. So in order for it to be a solution, it had to be in that purple area where the two shadings come together. So hopefully that makes some sense there. Let's take a look at our next example. This one, they've given us a graph, and they've asked us to write a system of inequalities for that graph. And so thinking back to how we write this inequality, we can use our slope-intercept form. So for this one here, we have a y-intercept of 3, and we would have a slope. It goes down 1 and to the right 1 every time. So it has a slope of negative 1. With our other one here, we have a y-intercept of negative 5. And for this one, it goes up 1 and to the right 1 each time. So we would say it has a slope of positive 1. So for this first inequality, the one that's coming downward, slope is negative 1, so that's negative 1 times x plus 3. And our shading is below that line. So that means that y is less than that negative x plus 3. Our second one here, our slope is positive 1, so that's 1 times x minus 5, y-intercept is negative 5. And for this one, the shading is above the line. And notice it's a solid line instead of a dashed line. If it's solid, then that means it's greater than or equal to. This one had the dashed line. We don't have that equal to there. And so this would be our system of inequalities. Now, I've also graphed this in Desmos just so we can check to make sure that we've got it right. So let me pull that up. Less than negative x plus 3. That's the red shading. Greater than or equal to x minus 5. That's our blue shading. And so the purple area here, like we saw, that's what they shaded on their graph. That's the solution that works for the entire system for both inequalities. All right, one last problem here to look at. And this one just asks us to graph the system of inequalities. If I was going to graph it by hand, I would probably go ahead and get these into slope-intercept form. So I want to get that y by itself. So for the first equation, I just have to subtract that x to the other side, and it becomes y is greater than or equal to negative x plus 5. And for this one, I add the x to each side. I get negative y is greater than negative x plus 3. I want to know what y is, so I have to divide everything by negative 1. When I divide by a negative, that's going to change the direction of our symbol. This becomes positive x minus 3. So our two inequalities in our system would look like this. We could graph, and let me pull it up on Desmos here. So I went ahead and graphed them as they were given, and you can see our shaded area here in the purple, that's going to be our solution area. All right, and that's all I've got for you today. Appreciate you taking the time to watch. As always, if you have questions, please let us know. Thanks. Have a great day.